we're going to start our last unit, which is on limits, talking about what a limit is, when do they exist, and how do we evaluate them. So we'll start off with the definition of a limit, how limits differ from function values, when they exist versus do not exist, how to determine if a limit exists by looking at the left-hand and right-hand limits, and evaluating using substitution and factoring. So the limit L of a function f of x is the intended height of the function when x equals c. So the way this is read is, what's the limit of f of x as x approaches c? For many functions that we are familiar with, the limit and the function value will be the same thing, because the function value would be the height at a specific x value. Discontinuities like holes and asymptotes, and then there will be some other features, will introduce a difference between the limit and the function value. The limit is the value that the graph appears to be approaching as x gets closer and closer to c. So a parabola is an example of a function that we're really familiar with and has an easy to determine limit. So taking a look as x approaches -2, we can read from our graph here that the height at -2 is 3. So we'd say the limit of f of x as x approaches -2 is 3. We could also plug in, like, the value of the function at -2 equals 3. This is a case when they're the same. But when we have things like holes, particularly if the hole gets filled in, the values might be different. For example, the value of f of 2, or sorry, g of 2, looks to be something like, let's say, 4.25. Sorry, 1, 2, 3, 4. Yeah, 4.25. However, the graph appears to be approaching this value here, which looks closer to 3. And I'm estimating here a little bit. So the function value and the limit disagree at that point, because this hole here is where the graph appears to be approaching, not the point that fills in the hole. Limits do not exist when the graph appears to approach different values when x equals c. So for example, these two, which we'll look more in depth later, we have the graph approaching a height of 2 and a height of 4, and the hole is filled in at 3, so we have lots of different values for that one. As the function approaches 3 down here, we have this side heading towards negative infinity, and this side heading towards positive infinity. So they're approaching different values. Looking at the two values that a graph approaches is called using the left and right hand limits, which are notated by these tiny little markings here. I mean, we're already writing small because we're writing in the limit notation. But the left hand limit is coming from the negative side. The right hand limit is coming from the positive side. So let's take a look at those. So the value at 1 for this example is 3. The limit as we approach from the left-hand side is 2. The limit as we approach from the right-hand side is 4. And so the limit does not exist. In this case, there is no function value at f of 3, so that does not exist. But the limit still could, so let's keep evaluating. As we approach from the left-hand side, we're heading towards negative infinity. As we approach from the right-hand side, we're heading towards positive infinity, so the limit still does not exist. When we want to evaluate limits, sometimes it's as easy as substitution. For example, if we look at this polynomial here, if we're trying to evaluate the limit as x approaches 5, we can just plug 5 in and we find that the limit equals 39. Same thing with the second example, plugging in -2, tells us that the limit will be -1/11. However, if substitution leads to dividing by 0, so for example, this one we would have 4 minus 4, and we can't divide by 0, we'll need to factor out and cancel. So the numerator and the denominator factored give us a matching pair of factors, which leaves us with x plus 6 over x, which we can evaluate. 2 plus 6, so I'm pulling the 2 in from here, over 2 equals 8 over 2, which is 4. We covered a lot of material pretty quickly here. These are just some of the basics. Tomorrow in class, we'll go through this more in depth.